All right, 1.3, using midpoint and distance formulas. Starting off with definitions. A midpoint is the point that divides a segment into two smaller congruent segments. All right, so if we have a segment here, and something is right between it, cuts it in half, right? And those two smaller pieces are equal, right? Cutting it in half. A segment bisector is a point, a line, a ray, or a line segment, or a plane that intersects the segment at the midpoint, okay? So the midpoint is the spot where it's cut in half. The segment bisector is the thing that cuts it in half, okay? And the word bisect, hopefully we know that. To bisect means to cut in half, or to break in half, to separate in half. All right, number one. Identify the midpoint and the segment bisector of segment AB. Then find AB, find the length. So we have the midpoint M, so the midpoint is M. Remember, the midpoint is the spot where it's cut in half, right? The segment bisector, is the thing that cuts it in half. That's going to be this ray here, ray MN. All right? So we're just trying to find AB. We have these two pieces that are cut in half. It's marked on there that they're equal. We have some x's in there I'm going to have to solve. So I'm going to say, to start off, 3x minus 4 equals 2x plus 1. Whenever I solve, I'll subtract 2x from both sides, and I'll add 4. That leaves me with x equals 5. Now I'm going to plug my x in to get my actual length. So I'll say 3 times 5 minus 4. What's that going to give me? 3 times 5 is 15, minus 4 is going to be 11. And I'll do that to the other side as well. So 2 times 5 plus 1. Well, 2 times 5 is 10, plus 1 is 11. So that makes sense. Each half is equal to the same thing, right? They're both equal to 11. So my whole thing, AB, is going to be equal to 11 plus 11, which is 22. So AB is 22. All right, there we are. Number 2. Now this is going to be one where I can't really show you how to do it, but I can explain it. Starting off, we're going to draw a segment. A, B. And then it says construct the segment bisector by paper folding. And that means literally fold your paper. And let me show you how I want you to fold your paper. I want you to fold it to where B and A match up. Okay? So take that and crease it, and you should get a crease right there whenever you fold your paper. What we've done, that crease is the segment bisector. It cut it in half, right? So we have our midpoint, point M, and then we have our segment bisector, which is that orange piece. That's the crease on your paper. All right, cool. Next up, the midpoint formula. The midpoint is halfway between the endpoints, right? That makes sense. It is the average of the endpoints, right? Halfway between something is kind of like averaging it, right? So what we say is we have A at x1, y1, and B at x2, y2. Then the midpoint is going to be at x1 plus x2 over 2. Now let's look at that for just a second. What that does is it takes the x's, it adds them up, and it divides them by 2. That's how you find the average of two numbers, right? If I told you to find the average of 1 and 5, you would add them up and then divide by 2, right? 1 and 5 would give us 6, divided by 2 is 3. And 3 is halfway between 1 and 5. That's what we're doing here. It has some variables, so it looks a little uglier, but that's what's happening. And then we have the same thing, y1 plus y2 over 2. Now we're talking about in this one, if we had like a coordinate plane where we had A being like, I don't know, -5, 3, and then B being, I don't know, 2, 1, okay? That would be how to find the spot halfway between them there. All right? Let's do an example, and hopefully it makes a little bit more sense. The endpoints. The endpoints of segment RS are R, -8, 7, and S, 5, 1. Find the coordinates of the midpoint M. So I'm not going to draw this too well, but I'm going to show us about what it is. R would be over here, and S would be over here. This is segment RS, and we want to find the midpoint halfway between it, right? I'm going to use my midpoint formula. So my midpoint, and I'll call it M, is going to be at, I average my x's, so I'm going to take -8 and 5, -8 plus 5 divided by 2. And then I'm going to do that same thing to my y, so I'll have 7 and 1. So 7 plus 1 divided by 2. All right, so M will be, well, -8 plus 5, what is that? 5 minus 8 is going to be -3 over 2. And then here I have 7 plus 1. 7 plus 1 is 8. Divided by 2 is 4. So my midpoint is at -3/2, 4. Which if we look back at our picture, -3/2 would be somewhere in this region. And then up 4, somewhere in there. So my picture wasn't perfect, but I think we can kind of see that it was close. Number 4, the midpoint, let me give some more space. The midpoint of segment JK is M2, -3. One of the endpoints is J4, 1. Find the coordinates of K. So what I'm going to do here is I'm going to say, well, K, we'll say that you are just plain old X, Y. Okay? We're going to have to find X, and we're going to have to find Y. Let's draw a rough sketch of what we think this is going to be. J is at 4, 1, so it'll be here. M is at 2, -3, that'll be here. So that would make K somewhere in this region. Okay? Now in this one, instead of using the midpoint formula as one big thing, I'm going to kind of separate it apart. I know that the midpoint, I'm going to first start looking at the x's here. The midpoint M is the average of my x values. So I'm going to take 2, I know that's what I got, that's my midpoint. The midpoint is my x's added together divided by 2. So I'm going to have one of them being x, one of them being 4, divided by 2. All right, and we're going to have to solve that, but I'm going to write my y1 next. For y, I have -3. That's going to be equal to my two y's added together. One of them is just a plain old y, and the other one's a 1, divided by 2. All right. Again, what I'm saying here is I have my x and my other x divided by 2 to give us my midpoint. So let's solve this one on the left. To do that, I will multiply both sides by 2 to get rid of the denominator. and that's going to give me cancel on the right, and I'm going to get 4 equals x plus 4. All right, I'll subtract 4 from both sides, and I'll get 0 equals x. Now let's work on the right side here. Again, I'm going to start off by getting rid of that fraction. I'm going to multiply everything by 2. On the right side, it cancels. On the left side, I'll have negative 6 equals y plus 1. I subtract 1 from both sides, and I get negative 7 equals y. So what I've done here is I've found my point K. It's supposed to be at 0, negative 7. Right? You can look at my picture and say, well, Mr. Carrington, you really did a really bad job with your picture. And yeah, I did. The point K should be somewhere in this region. So I didn't do a super great job with my picture, but we know that the math works out, okay? Let me draw a little divider here. There we are. All right. Now, next up, remember the Pythagorean Theorem. Now, you don't have to write this down. It's just to kind of help us remember some things. Pythagorean Theorem has to do with a right triangle where we have like A, B, and C, where we know that A squared plus B squared is C squared, right? Now, what I want to do really quick here is I want to solve for C. Now, to solve for C, I'm going to take the square root of both sides. So C, I'm going to, well, here, I'll say square root of A squared plus B squared equals just plain old C, okay? Now, we're going to do the distance formula in just a second. And what we're going to be doing is we're going to be finding the distance between 2 points, right? And if my 2 points are the 2 green points, the distance between them would be line C, or segment C. So I'm going to have to find out how long is C, okay? And it looks a little bit uglier than this whenever we actually do it, but hopefully it'll make a little bit of sense. So this is the distance formula. If we have 2 points, A and B, then our distance is going to be the square root of our x values subtracted squared plus our y values subtracted squared. With the Pythagorean theorem, what this would look like would be C equals the square root of A squared plus B squared. That's where that comes from. So let's try to use the distance formula. Let's try to use it. Now, if you didn't understand the whole Pythagorean theorem and how that kind of goes into the distance formula, that's okay. I really just want you to be able to use the distance formula. That's what I need you to be able to do. Number 5. The endpoints of segment RS are R, negative 8, 7, and S, 5, 1. Find RS. So here I'm going to use my distance formula, and I'm going to label everything first. Here I have x1, y1, x2, y2. So my distance is going to be equal to big square root. I'm going to have 2 sets of parentheses squared. And now I need to plug in for my variables. We look at my distance formula up here, and it has x2 minus x1. Here's x2, so I'm going to have 5 minus x1, which is negative 8. So it's going to be 5 minus negative 8. All right, and for our y's, I'm going to have 1 minus 7. Okay. The rest of this is just kind of doing the algebra of it. Okay, we've done the big meat of the problem. Remember that if we have a double negative where we have 5 minus minus 8, that turns into a plus. So I'm going to have big square root 5 plus 8. And also, I highly suggest that you don't try to type the whole thing in the calculator right away. Okay, there's way too much here to type in a calculator, and you'll probably end up messing up if you do it. So 5 plus 8, 5, 6, 7, 8, that'll be 13 squared, plus 1 minus 7 is going to be negative 6 squared. Now I'm going to type this in my calculator, 13 squared. That gives me 169. And negative 6 squared is going to be positive 36. All right. Now, if I can find a calculator sitting near me. Oh, here's one. I'm going to type in my calculator 169 plus 36. That gives me 205. So this is going to be equal to the square root of 205. And now that we have all of it simplified, I'm going to take my calculator and I'm going to type in the square root. So I'm going to type in square root of 205, and I get 14.3. And we'll just leave it right at 14.3. So that's how long that segment is, okay? To write our answer, we're going to say that RS equals 14.3, okay? All right, I know that's kind of a long problem. I know that that's kind of confusing with the distance formula, but hopefully we're able to work our way through it. Always make sure that you have this distance formula, the actual formula, written somewhere, okay? You're going to need to reference that for a lot of homework problems. Number 6, your school is 4 miles east and 1 mile south of your home. Your friend's house is 5 miles east and 2 miles north of your home. Estimate the distance between your friend's house and your school. All right, so let's start off by drawing a picture. We'll have a dot. This is home. Okay, your school is 4 miles east, and east is normally right to the right of us, right? So I'm going to say 4 miles east and 1 mile south. I'm going to go right 4 and down 1. So 1, 2, 3, 4, and down 1. That puts a dot right there. And that is the school. Your friend's house is 5 miles east, right? East is still to the right. So 5 right and 2 up. 1, 2, 3, 4, 5 right and 2 up. This is the school. Estimate the distance between your friend's house and your school. Oh, excuse me, I mislabeled that. This is supposed to be the friend's house. I'm sorry. All right. So we're wanting to find this. How far away is the friend's house from the school? Now what I'm going to do is I'm going to draw a right triangle, and I'm going to use the Pythagorean Theorem here, because I think that's a little bit faster. So if I draw my triangle in here, there's my little right angle. I know that this is 1 unit, and I know that the other one is 3 units. And then I have my C, or you can call it X, you can call it whatever you want. That's going to be your hypotenuse, right, the long side. So I know that 1 squared plus 3 squared equals C squared. 1 squared is 1, 3 squared is 9, equals C squared. 1 plus 9 is 10, equals C squared. So C is the square root of 10. And let's go ahead and type that in a calculator. Square root of 10, that gives me 3.2. So we'll say 3.2, and what's our units? Our units are miles. All right, so hopefully that makes sense. That's the last of it. Good luck on your homework, and let me know if you have any questions.